Move to this beautiful question. To start with, we need to understand this 1 plus x square plus x cube plus x power 4. And how do we get that? There's a 1 minus x whole power 51 here and power 50 here. And so think of this like a geometric progression. With the first term 1, common ratio x. Anyway, 1, 2, 3, 4, 5. Sum of all of this, you can reimagine this. First term is 1, common ratio is x. You want to sum up to 5 terms. You think about it like that. Then this is AR power 5 minus 1 by R minus 1. This can be rewritten like this, which is brilliant because now I can reimagine this whole thing as 1 minus x power 51 into x power 5 minus 1 power 50 by x minus 1 power 50. Brilliant. X minus 1 power 50, 1 minus x power 51, we got it as x minus 1 power 50, 150 whole 1 minus x power 50 will get cancelled and completely. Or we can write it as 1 minus x power 5 whole power 50, either way is fine. So I'm going to cancel off x minus 1 whole power 50. X minus 1 whole power 50 and 1 minus x whole power 50 are same. Power 50, plus or minus, it doesn't matter. I can knock that off completely. So what I'll be left with is 1 minus x into x power 5 minus 1 whole power 50. Nice, brilliant. Now that this giant thing is simplified to this simpler thing. Not yet done, mind you, not that easy. So we say, hey, this I can expand. Our typical binomial expansion thing. So this will be 1 minus x into, there will be a x power 250 term and there will be a 1 term. After that, there will be an x power 245 term, x power 240 term. There will be a total of 51 terms. So x power 5 minus 1 whole power 50, 51 terms will be there in that expansion. That's a starting point. Each term, you will have x power 5 whole power 0, x power 5 whole power 1, x power 5 whole power 2, x power 5 whole power 3, all the way till x power 5 whole power 50. There will be an x power 250 term, 245, 240, all the way till x power 10, x power 5, and then 1. It will be plus and minus alternately, all of that. I don't care about the value, I don't care about the coefficient, I don't care about any of those. All I want to know is how many terms will be there. Okay? And then this I'm multiplying with this. The one thing will have all x power 250, 245 terms. I multiply by x, I'll have x power 251, x power 246, x power 241, one additional x. These are all steps of 5. And then I'm adding one more x. So there will be x power 251, 246, 241, all the way till x. No, this into this will give me 51 terms. This into this will give me 51 terms. All 102 coefficients will be different. These are all steps of 5. These are all steps of 5 plus 1. There is no overlap at all. So there will be 51 plus 51, 102 terms. Just knowing that 1 plus x square plus x cube plus x power 4 can be thought of as x power 5 minus 1 by x minus 1, super useful. Or 1 minus x power 5 by 1 minus x, super useful. And so if you can think of this as x power 5 minus 1 by x minus 1, this question just gets unlocked. This expansion we know that it will have 51 terms. This has 2 terms. 2 into 51 is 102. It's not always 100, it doesn't always work like that because a bunch of terms can have the same coefficient. This idea is important. So I'm going to do a very simple example. Suppose you do a plus b into a plus b. This 2 into 2, 4 terms. But how it works is this is a square plus ab and a ba plus b square. Only 3 terms. So multiply one expression with 2 terms, another expression with 2 terms. I can get up to 4 terms. But if the algebraic part of 2 of the terms are same, they'll combine. That's how we multiply 2 polynomials. So it will be only a square plus 2ab plus b square. In this case, we cannot just look at this and say 51 into 202. Bunch of those there could be overlap. Having said that, in this case there's no overlap because these are all steps of 5. Multiplying by 1, it will all stay as it is. Multiplying by x, each one will become steps of 5 plus 1. Multiply 5 plus 1. No overlap at all. 51 terms plus 51 terms, 102 terms are there. Beautiful question.